This is part 2 of our series highlighting the process benefits of upgrading your aging brush rotors to disc aerators. You may already know me if you viewed the first of our presentations in which I discussed the mechanical advantages of the Evoqua disc aerator in oxidation ditch applications. If you have 10 minutes today, I would like to tell you about the significant advantages that can be gained by operating oxidation ditches in series with Evoqua disc aerators. These include significant reduction in aeration energy, the ability to upgrade to biological nutrient removal, and increased operating flexibility to handle excessively high storm flows. If you have an existing plant with brush rotors in oxidation ditches, converting the ditches to operate in series with Evoqua disc aerators should be considered, especially if you are faced with new or more stringent effluent requirements. This conversion is simple and requires no additional tankage. Typical brush rotor oxidation ditches operate in parallel, with flow entering and exiting each ditch independently, and with DO typically maintained at 2 milligrams per liter in each. To convert to series operation, flow is routed from one ditch to the other. They now can be operated at different DO concentrations, which has important benefits we will discuss next. As just mentioned, in parallel operation, both ditches typically operate at 2 milligrams per liter DO. Denitrification is not expected in either ditch because of this excess oxygen condition. At the right are two ditches operating in series. Oxygen is supplied to the first ditch, shown at the top, but not enough to create an oxygen surplus. Operating at 0 DO in the first ditch creates an anoxic condition. Since O2 is provided in the process, but an oxygen deficit condition exists, we have termed this an aerated anoxic condition. This anoxic condition in the first ditch drives considerable denitrification, up to 80%, while the oxygen supplied allows for nitrification. Final nitrification is completed in the second ditch, our oxygenation zone, in surplus oxygen conditions. This saves treatment space since the third anoxic zone, typically used in conventional biological nutrient removal processes, is not required. Overall, less oxygen is used in an aerated anoxic process. For a 2 MGD flow condition, power draw is reduced from 130 horsepower to 95 horsepower, or between 25 and 40%. In summary, operating in aerated anoxic conditions allows for true simultaneous nitrification-denitrification in the same zone, which saves power and eliminates a separate anoxic tank. I want to clarify one common misconception. An oxidation ditch with aerobic and anoxic zones is not the same thing as an aerated anoxic reactor operated in series with an aerobic reactor. In a single ditch, the oxygen supply must exceed the oxygen demand to ensure complete treatment. Balancing this requirement while trying to maintain separate aerobic and anoxic conditions in a single reactor is very difficult to control with the varying loads that most plants experience during the day. Conventional single-train oxidation ditches are just not conducive to creating the aerated anoxic conditions required for true simultaneous nitrification-denitrification. Separate reactors operating in series are required. We've explained important benefits that can be gained operating oxidation ditches in series. In addition to these, series operation provides flexibility for tailoring biological nutrient removal to emphasize total nitrogen or biological phosphorus removal. Here are two examples. The ditches shown on the left are set up for TN removal. The oxygen delivery is the same in both ditches. Aerated anoxic conditions are maintained in the first ditch at the top, while an excess oxygen condition is maintained in the second ditch. An internal recycle of 4:1 from ditch 2 to the first ditch is added to allow up to 90% TN removal. If the treatment objective is phosphorus removal, as shown on the right, oxygen delivery in the first ditch is reduced to establish an even stronger oxygen deficit condition. This arrangement allows an effluent P of less than 1 milligram per liter to be achieved without chemical addition. Another advantage of operating ditches in series is the ability to handle excessively high storm flows. The example on the left shows the solids load to the final clarifier of 3,500 pounds per hour during normal operation. The example on the right illustrates a 5 mgd storm flow event. The solids load to the final clarifiers jump to 10,500 pounds per hour, which overloads the clarifier. So you can see the difficulty in avoiding clarifier overload conditions during a storm flow event when ditches operate in parallel. Using the same flow conditions, we can see how excess storm flows can be easily handled if ditches operate in series. As before, the basins on the left are operating at normal conditions. The right illustrates operation during a storm flow event, directing 100% of the RAS to the first ditch and 100% of the storm flow to the second. The mixed liquor of the second ditch drops to 1,500 milligrams per liter, while the RAS decreases to 8,500 milligrams per liter. This can occur in less than 60 minutes. Under these conditions, the solid load to the final clarifier is 3,000 pounds per hour, a lower loading than under normal conditions. When operating ditches in series, a clarifier solids overload condition can be avoided and good effluent maintained during the storm flow event. Converting oxidation ditches to operate in series is made easier by the simple addition of a smart B&R process control system. Our extensive experience with aerated anoxic operations is programmed into algorithms to optimize plant performance. The smart B&R process provides precise controls for simultaneous nutrient removal in a single reactor. It incorporates predictive aerator response to changing reactor conditions, features integrated ORP and DO control strategies, features automated sludge wasting to maintain an optimum sludge age, and includes automated storm flow response controls. The smart B&R system empowers operators, cuts energy cost, and enhances system reliability. To recap the process benefits gained by installing the Evoqua disc aerators in series. They provide the most efficient environment for simultaneous nitrification-denitrification. Treatment requirements are achieved using less power, 25% to 40% less than conventional processes. Can be operated to optimize in total nitrogen or biological phosphorus removal. Offers an effective solution of handling storm flow events. Can be automated with smart B&R controls. Evoqua recommends enhancing secondary treatment by operating disc aerators in series. It is a simpler way to achieve B&R in oxidation ditch processes.
Well, that concludes my talk. But even though I'm giving this presentation, I'm certainly not alone in supporting your application needs. At Evoqua Water Technologies, we have a team of Envirex biological process experts ready to help you upgrade your plant. If you have additional questions, please do not hesitate to contact me. Thank you for your attention. I enjoyed our time together.